Now, there are many components that contribute to the success of the transmission and the reception of a radio frequency signal. So if you think about it, there is some device, a laptop, computer, something that is sending data into what we would call the transmitter. The transmitter here is the thing that's going to have that AC power and is going to be responsible for how it basically sends out the signal so that it can be interpreted as ones and zeros, which we call the modulation. But from that transmitter, we have this copper cable, we call it this antenna cable, that the power has to go through. Now, if you think about it, anytime we start sending current over a cable, there's going to be a little bit of a loss of power. It's the physics, it's in traveling distance, that electrical signal is going to get a little bit weaker. And we're going to talk about that and why that's important to us as we move into the math. And then we have this thing called the Intentional Radiator. And what that's going to do is basically put that power onto the antenna. And depending on the design of the antenna and the type of power that's being sent, we're going to come up with what we call the EIRP, or the actual strength of the radio waves. And that antenna is then going to either omnidirectionally or more focused, depending on the type of antenna, send that signal across the air, hoping that the receiver over here gets that. Now, what are they going to basically do? That receiver is going to be able to translate that message as a bunch of ones or zeros, and basically send it back to the receiver, the antenna is, I should say, and then from there it's going to go back to the receiving device that wants to see that data. Now, as we look at this picture, and you'll see it a couple other times, we're going to start talking about how the different components can affect the overall power and quality of the signal that we're going to send.